Hello students, today we'll discuss IB Physics SL Paper 2, May 2021, time zone 1. In this paper you should use calculator. My name is Nariman Melim. I am located in Baku and here you can see my mobile and email in Baku. To prepare for exam you need the following sources. Main huge textbooks from Oxford, short textbook by Tsokas, or for revision and deeper understanding, study guide by Tim Kirk. Even for this paper, now on, you need physics data booklet, first assessment 2016 copy, and I recommend you also to look through IB Physics Guide 2016. Let's start. Paper 2, May 2021, Monday, 3rd of May, 1 hour 15 minutes. First question. Two players are playing table tennis. Player A hits the ball at height 0.24 meters above the edge of the table, measured from the top of the table to the bottom of the table. The initial speed of the ball is 12 meters horizontal. Assume the air resistance is negligible. Show that the time taken for the ball to reach the surface of the table is about 0.2 seconds. So we have projectile motion. So ball participate in two motion, forward or horizontal motion at constant speed because air resistance is negligible, and downward acceleration with g equals 981. So I will use formulas from booklet, section 2.1. So horizontal displacement is vertically down, so we have acceleration is positive, initial velocity vertically is 0, so 0, s equals height equals 0.24, g equals, so we put this data into the formula, rewrite it for t squared, then make square root of both sides, and we give answer to round to one significant figures as they want. So we get 0.22 and so on, but we round to 0.2 seconds. Sketch on the axis a graph showing the variation with time of the vertical component of velocity. Take g to be 10. Right, so let's do it. So when ball moves down, ball accelerates downwards. Just a moment, I'll change keyboard. Ball accelerate downwards. So velocity will increase at rate a, so formula is v equals u equals a t. At time 0 velocity is 0, at time 0.2 second velocity will be 20, so we put these 2 points 0 0 and 0.22 and draw straight line because gradient equals acceleration is constant, so straight line graph. Part C, the net is stretched across the middle of the table. The table has a length of 2.74 meters and the net has a height of 15 centimeters. Show that the ball will go over the net. So to reach the position of the net, we should travel horizontally half of the length of the table. It is 137 meters. So ball is moving at constant speed, so time taken will be distance by velocity, so much with 3 significant figures. if we send y-axis upward and start from the table, so from the surface of the table 0, then initial coordinate is the height 0.24, and it will be decreased by displacement. Displacement is given by gt squared 2. So we put value g10, we get the value 17.45 centimeters. It is greater than 15 centimeters, so ball goes over the net. Part D. The ball bounces and then reaches a peak height of 0.18 meters above the table with a horizontal speed of 10.5 meters per second. The mass of the ball is 2.7 grams. Determine the kinetic energy of the ball immediately after the bounce. So after the bounce, all energy is kinetic, then total energy is conserved, and ball's kinetic energy decreases, but potential energy increases, but total energy stays the same. So we change mass into kilogram and use subtopic 2-3 formulas for kinetic energy, potential energy. Just after bounce, all energy is kinetic. Later on, the total energy is kinetic plus potential, so we put values at some height, and we get 0.15 joules, two significant figures, because most of the data is with two significant figures, right? So minimum with two significant figures. Player B intercepts the ball when it is at its peak height. The player holds a paddle, stationary and vertical. The ball is in contact with the paddle for 0.010 seconds. Assume the collision is elastic. Calculate the average force exerted by the ball on the paddle. State your answer to an appropriate number of significant figures. So, not in the booklet is the following information. For elastic collision, relative speed of approach equal relative tip of separation. Hence, ball bounces with velocity minus 10 meters per second, so mass is so much, time is so much. Subtopic 2.4 give us formula for momentum and change of momentum. We rewrite formula for change of momentum for force. So change of momentum will be momentum final minus momentum initial. It is 2 times momentum of the approach, and then we divide this by time. We get 5.7, two significant figures, Newton. Question 2. A planet is in a circular orbit around the star. The speed of the planet is constant. Explain why centripetal force is needed to the planet to be in circular orbit. So I copied answers from Mark's scheme. So when object is moving in a circle, force should be at 90 degrees to the velocity all the time, not to change this speed, but to change the direction. State the nature of this force. It is gravitational force of attraction. Determines the gravitational field of the planet. The following data are given: mass of planet, radius of planet. So mass of planet we have, radius we have, g is taken from booklet. Subtopic 6.2 give us gravitational field strength. It is gm over r squared. We put the values and we get 6.4 Newton per kilogram. Question 3. A mass of 1 kilogram of water is brought to its boiling point of 100 degrees Celsius using electric heater of power 1.6 kilowatt. AI. The molar mass of water is 18 grams per mole. Estimates the average speed of the water molecules in the vapor produced. Assume the vapor behaves as an ideal gas. So we change temperature into Kelvin. We need Avogadro number. So from subtopic 3.2 we understand that kinetic energy depends only on temperature, and we need also Boltzmann constant from data booklet, and at the same time kinetic energy is half mv squared. So half mv squared, we square both sides and rewrite for v, and we use calculated value of energy. So to find mass of one particle or molecule, we divide molar mass 18 gram mole by Avogadro number. So we get 720 meters per second. Here mistake, it should be second. -1, not -2, just -1, just a moment. Two significant figures, so meters per second. Double I state one assumption. Of the kinetic model of an ideal gas. So I copied answers from Mark scheme. So look, pause the video and read these answers. Okay, so it's your choice to remember at least one of them. B. A mass of 0.068 kilogram of water remains after it has boiled for 200 seconds. I. Estimate the specific latent heat of vaporization water. State an appropriate unit of your answer. Change of mass. So mass boiled will be difference. What was given. So much was vaporized. Time given. Power given. Note in booklet, power equals energy over time. It means energy equals power by time. Subtopic 3.1 give us energy and specific latent heat. So energy we take from energy we take from power times time. At the same time, it is mass times specific latent heat. So formula for latent heat is PT over mass. And we put the values and we get 2.3 times 10 to the 6 with two significant figures. Actually, this is the value for water, so you can memorize it and check that you got approximately correct answer to two significant figures. So explain why temperature of water remains at 100 degrees Celsius during this time. All the energy added is used to increase the intermolecular potential energy of the particle, break intermolecular models, but not to increase kinetic energy, because kinetic energy depends on temperature. Temperature is constant, means that only potential part is changing. C. The heat is removed and mass of 0.30 kg of pasta at -10 degrees Celsius is added to the boiling water. Determine the equilibrium temperature of the pasta and water after the pasta is added. Other heat transfers are negligible. We are given specific heat capacity of pasta and water. Heat leaving the water equals heat entering pasta. So from subtopic 3.1 we have formula for temperature change and energy given. Using this formula and also rewriting equation 1 using this formula, we get on the left for water, heat leaving, on the right for pasta, heat entering. So temperature of water decrease from 100 to T, so changes 100 minus T. For pasta increase from minus T to T, so difference is T minus 10. So we put masses of water and pasta. We put specific heat capacity for water and pasta, and we rewrite formulas and find T to two significant figures. It is 86 degrees Celsius. D. Electric heat has two identical resistors connected in parallel. The circuit transfers 1.6 kilowatt when switch A only is closed. The external voltage is 220. Shows that each resistor has resistance of about 30 ohm. So power we change into watt. Subtopic 5.2 give us formula for power voltage squared over R. We rewrite this formula for R resistance. We put the values and we get to two significant figures, 30 ohm. Calculate the power transferred by the heater when both switches are closed. Method 1. So we have formula again for power voltage. This time it is total resistance. Total resistance will be 2 times less, 15 ohm, and we get 3200 watt. On the method 2, This is smart method. Parallel connections. It means that two identical resistors at the same voltage, so its power increased 2 times, comes to 3200 watt. Question 4. A planet orbits a distance d from a star. The power emitted by the star is P. The total surface area of the planet is A. Explain why the power incident on the planet is so much. Surface area of the planet is A. A over 4 is PR squared. So we'll keep it. Then, power radiated by star on unit area at distance d is power divided by surface area at distance d, 4 pi d squared. So this is the power incident on meter squared, and it falls on PR squared of the planet. But PR squared of the planet is A over 4, so we multiply these two factors and we get the answer. The albedo of planet is alpha P. The equilibrium surface temperature of the planet is T. Derives the expression like this, where E is emissivity of the planet. Subtopic 8.2 give us power emitted by object at temperature T. Albedo is total scattered by total incident. From albedo we get power scattered equals alpha P by P. So power incident, we use our previous formula and we get this expression. So power incident equals power scattered by power emitted. It is conservation of energy. Power incident is P. Power scattered is alpha P by P. Power emitted is the formula from the booklet. After putting expression for each and rewriting for T4 to the fourth power, then we make find fourth root to find T, and then we see that the power falling on, so the solar constant, so we got the formula actually. We don't need to calculate. So you can pause and look more attentively to the information given. Right, then, so this is information given. Solution. Part B. On average, the moon is the same distance from the sun as the Earth. The moon can be assumed to have emissivity of 1, albedo 0 of 13, solar constant is so much. Calculate the surface. So here we understand that P over 4 pi d squared is solar constant. So this expression is solar constant, and the rest we can substitute, and we get to two significant figures, 270 Kelvin. Question 5. Radioactive uranium produces a series of decays ending with a stable nuclide of lead. The nuclides in the series decay by alpha or beta processes. Uranium-238 decays into nuclides thorium-234. Write down the complete equation for this radioactive decay. So I added thorium, 2034 atomic mass, X is unknown, particle is unknown, but from top number balance we understand the particle has 4 nucleons, so it is alpha particle. It means that Z is also 2. If Z is 2, X is 90. So for thorium, proton number is 90, so finished. Thallium decays into lead. Identifies the quark changes for this decay. So what we see that number of protons increase 2 times at the account of neutrons. So 1 neutron turned into proton. From subtopic 7.3, we see the structure of the matter, and we understand that this happened because down quark turned into upper quark, or complete quark flavor of neutron is UDD, proton flavor is UDD, so down quark turned into up quark. As a result, charge increased. So here increased by 1. Increase in charge by 1. Next question. The graph shows the variation with nuclear number of binding energy per nucleon. So here we have nuclear number and binding energy. So we have maximum. So it means that if we have 2 light nucleons, they can combine. As a result, we will move to the right. Or one heavy nucleon will divide into 2, we will again move to the maximum. So binding energy will increase. Outline why high temperature are required for fusion to occur. High temperature corresponds to high kinetic energy of particles. High kinetic energy is required to overcome Coulomb electrostatic repulsion. Outlined with reference to diagram why energy is released both in fusion and in fission. Energy is released when binding energy per nucleon increases. Uranium-235 is used as a nuclear fuel. The fusion of uranium can be produced krypton and barium, determined in megaelectron-volt, and using the graph the energy released by this fusion. I will show only, for example, for uranium-235. Uranium-35, we use a graph, so we get about 7.6 for this nucleon, 7.6 mega electron volt. In the same matter, using graph, you can find that for chromium, for atomic number 89, it is about 8.6, and for barium 144, binding energy is 8.2. So calculating binding energy before and binding energy after, we get difference 160 mega electron volt. So this energy is negative. This is why binding energy is actually decreasing, and as a result energy is released. On a guitar, the string plate vibrate between 2 fixed points. The frequency of vibration is modified by changing the string length using a finger. The different strings have different wave speeds. When a string is plucked, a standing wave forms between the bridge and the finger. Outline how so we have 2 points, and between these 2 points standing waves are formed, fixed points. Outline how a standing wave is produced on a string. Traveling wave moves along the string and reflects at fixed ends. So we have superposition of incident and reflected waves. The superposition is reinforced only for certain wavelengths. So this I took from Mach scheme, so choose any 2 ideas. The string is displayed 0.4 centimeters at point P to sound the guitar. Point P on the string vibrates with simple harmonic motion. Its first harmonic with a frequency of 195 Hz. The sounding length of the string is 62 centimeters. Shows that the speed of the wave on the string is about 240. So 0.4 centimeters is amplitude. First harmonic is 198. Length in meters will 0.32. Because we have node distance, it is equal to lambda over 2. It means that lambda is 2 times more, which comes to 1 24 meters. Using subtopic 4.2 for speed, speed equals frequency by wavelength, so we put numbers and we get 242 meters per second, so to two significant figures, correct answer. Sketch a graph to show how the acceleration of point P varies with its displacement from the rest position. So we have acceleration, displacement. Subtopic 9.1 give us formula linking acceleration and displacement. We see that they are proportional and we have minus here. So graph will be a straight line with negative gradient. So I have drawn this graph here. Question 7. Conservation of energy and conservation of momentum are two examples of conservation laws. Outline significance of conservation laws of physics. So I copied answer from the mark scheme. You can pause and look at these answers. When a pi meson quark composition is given and proton quark composition is given collide, a possible outcome is sigma baryon quark composition is given and kaon meson quark composition is given. Apply these three conservation laws to show that this interaction is possible. So we have smart method and straightforward method. Smart method, we put quark composition when simplify and use ideas that particle and antiparticle has opposite numbers, important numbers. So as a result of this simplification, we get up quark turns into up quark. So charge doesn't 0 equals 0, 1/3 equals 1/3, and strangeness, no strangeness, 0, 0. Straightforward method, for each of the quarks on the left and on the right, you put the value of charge. So you check that it is 0 on the left, 0 on the right. Baryon number, you check that it is the sum on the left is 1/3, on the right is 1/3, and strangeness on the left is 0 and on the right is 0. Here we finish the paper. Thank you for your attention. See you next time.